Hello, hope you're having a good day. Well, right now it seems like there's a thunderstorm outside, so if you hear some loud crackling, it could be the thunder. Today I'd like to talk a little bit about laws of propositional logic. This video assumes that you have read and done the participation activities for sections 1.1 to 1.4. In the first video on logic, I mentioned De Morgan's laws. In fact, we actually proved one of the De Morgan's laws, how a negation distributes over an and. You negate each proposition and you replace the and with an or. We proved that using a truth table. That is a law. And there are 11 laws, or 11 names for laws. Some of them have more than one part. And that's what I want to talk about today. So when are two statements equivalent to each other? There's several ways to do that. Well, we're going to talk about two ways to do that. One is to write down truth tables. That can get very, very tedious, especially if we have, say, 5 basic propositions. That means 32 different cases. That's a lot. And if there's 7 basic propositions, that's 128 cases to consider. I am not going to sit down and write them all out. That's where these propositional laws come into play. Like De Morgan's laws. Do I have to prove that again? No. That's a tool that I'm going to put into my toolbox. And whenever I see something like that, the negation of an and, I can replace that with the negation of the two propositions with an or in there. And that's the idea of today's video. I want to give you an example, show you a few little things, and then go ahead and read some of the sections that I have. So one of the big things we're going to talk about is how to use some of these laws. Some of them are rather straightforward, like the idempotent law. It basically says P or P is equivalent to P. You can't get any easier than that, really. Or P and P is equivalent to P. Now, just like with arithmetic, we have associative laws and commutative laws. Basically, the associative law says that you can group things any way you want, in either the or the and. The commutative says you can do them in any order that you want. Addition, 2 plus 3 is 3 plus 2. That's the commutative law. Distributive laws, they're a little bit harder to talk about. But distributive, how does multiplication distribute over addition? Well, that's basically what this says. If you consider these operators, the or and the and, as multiplication and addition, and I say like because if you do an exact match, things aren't going to work exactly. So what does the distributive law say? It says that an or statement distributes over an and statement in this fashion. And there's a whole bunch of them. I'd like you to read them. Here's a De Morgan law. This is the one we did right here. The negation of an and is an or of the negations. And here's the other De Morgan law. I want to talk about how we use these to shorten proofs. Shorten equivalences of statements. So using these laws, I have a problem for us to work on. I'm going to go over to the handwritten page. So this is the statement I want to prove. I put the word claim in front of it. I have a left side and a right hand side. When we want to show left is equal to right, there's several ways to do this. One, I can use truth tables. But that's not the point of this. I want to use the laws of propositional logic here. You know those 11 rules that I mentioned earlier on? So here's a technique that I don't want you to do. Keyword is don't. I don't want you to write down left equivalents and then keep writing down this right-hand side over and over again. That is not good technique. I want to be really careful about this. In order to do a proof like this correctly, we either start with the left-hand side and logically deduce the right-hand side, or start with the right-hand side and logically deduce the left-hand side. In this particular problem, I'm going to start with the left-hand side. In order to start with the left-hand side, I'm going to write down the left-hand side again. Do not skip these steps. So there's my left-hand side. I look at this and I say, well, there's a not, and I can distribute it over the and. This is in De Morgan's law. So the next thing I write down is going to be something equivalent to this using De Morgan's law. And I'm going to abbreviate De Morgan's law with DM. So this is what De Morgan's law says. If I distribute this not, the and becomes an or, and I negate each part. Do not combine too many steps into one line. Again, I can use De Morgan's law again. This is the other version of De Morgan's law. So this is equivalent to not P or, now here comes De Morgan's laws, not S and not P. Now I know some of you are saying right now, how come you didn't just write down P over there? Because we do know not P is just P. Well, that's another one of the laws. Whoops, double negation. I want you to write these down. You're writing down a recipe here. It's not just how fast you can get to the answer. You miss an ingredient, the cookies come out bad. Double negation. I know most of you wanted to write down this particular statement right away. Are you wrong? No. It's just not a complete proof then. At this stage, I have an or and an and. This is a distributive law problem. So I'm going to distribute this, not P, or not S. That's the first part. And not P or P. Now I'm going to quote Shakespeare again. This last term is basically to be or not to be. This is called the complement law. And I can replace that with a truth statement. A compound statement and true. This is one of the identity laws. I could write down not P or not S. And that gets me exactly what I wanted. In the Xi book, we have the participation activities, but there's also a challenge activity. And this challenge activity wants you to put things in the right order. So how is not Q and true equivalent to Q? Well, I'm going to walk you through this very, very quickly. So I'm going to select the law from the right to apply to this. So I think I'm going to apply this particular law. Now it tells me to select the item that I want in here and then apply the law. Now I have Q and true. I look on the list. This looks like the right form. And it says select the A from A and true below. So I'm going to select the Q. I'm going to click the next term. The true is the true. I'm going to apply that. And lo and behold, I got it right. So I wanted to show you two things. One, by hand, had a little bit of mess up myself. I think the thunder is really distracting me out there. It's very loud. And I wanted to show you a challenge problem. You will be responsible for some of these challenge problems coming up. I want you to have a great day. See you later. Bye.